All right, it's 11:30 where I'm at, so we'll go ahead and get started today. Thank you all very much for coming to our first Lunch and Learn for 2023. If you don't know me, I am Pam Finley. I am the Central Illinois Chapter President for 2023, and I just have a quick couple of announcements before we have our speaker take over. Here's our antitrust statement. Just remember, we don't want to talk about prices, product changes, anything like that that could get us all in trouble. And then I have a couple of announcements, reminders for upcoming events. Let me see if I can see them. Okay, so February 7th, we have a gentleman coming in from the Chicago Federal Reserve to do a lunch and learn with us. And then March 6th will be our ethics meeting, and details for that are to be determined. And without much more delay, I will turn it over to Mike Neubauer. He is technical underwriter here at RLI Insurance. And he actually put together this information for our construction council. And we thought it would be a great topic to share here with the Central Illinois CPCU. Mike, I'm going to turn it over to you, and you can start sharing your screen and go from there.
Great. Can you hear me?
Yes.
Okay, and share. Okay, looks like I'm up and running. Okay, so topic for today is going to be mass timber frame or mass timber construction. Start off just kind of this is really just an overview of kind of what it is, where it is, and some advantages, disadvantages, a little bit about kind of what's happening in that market. And as Pam had said, this is something I'd put together for our construction industry council. It's a group of people within our company, kind of across all underwriting lines, as well as various departments in the company that touch the construction industry. And it gives us an opportunity to kind of keep up with emerging trends. And this is one that I found interesting, and so did a paper on it. Okay, start off with just what is it? The mass timber is really just large panels and beams that are made of smaller pieces of lumber. So it's really, it's laminated lumber through either nailing, doweling, or glue. Here in a little bit, we'll talk through the various types of mass timber components that are used in various parts of the building process. Going to show you just a couple of examples up front here on the types of buildings that are out there now. Start with kind of the absolute largest right now. Believe it or not, it's actually in Milwaukee, Wisconsin, the Ascent. It's a 25-story luxury apartment building. It just opened up this summer. And we will talk also in here about building codes and the heights that can be built under the international building codes. Let's look first at the Ascent slightly here. Well, it's taking longer than I expected. Okay. So here what we have is really, there's a podium, and then there's 19 stories on top of it, was what that picture, these pictures cycle through. But I did at least want to show you that. And
Hey, Mike, we can't see the pictures.
you're right.
Thank you.
Thank you. Okay, so hopefully this is big enough because it doesn't actually blow up. But what we've got here is actually six stories of a concrete podium underneath 19 stories of mass timber frame construction. So even 19 stories is actually one more than the International Building Code. But it was approved in Milwaukee. Okay. Get rid of that. And kind of a bookend to that would be a small project. And what really piqued my interest to get going on this was 111 East Grand here in Des Moines. I'm in central Iowa, and moved back home to central Iowa about 1.5 years ago. And so about 6 months ago, I met with the developer of this building, just to talk to him about kind of what he learned from the process and kind of what the process was like to build this building. It was the first mass timber building in the state of Iowa. So we'll look briefly at that project too. So you can see in this, really, you've got beams and columns or posts, and then the decking. The decking on this, between, which is the floor or the ceiling, depending on where you're standing, I guess, is actually called dowel laminated timber, which is a form of mass timber, but it's individual pieces of lumber that are doweled together, and that's what holds them together. Believe it or not, there's actually not any glue used in it at all. And let's see. So you can see the building here. These columns here are actually steel columns that are clad on the outside to look like that. But the rest of the building, other than these along the side here, are all, once you get up inside the building, are all mass timber construction. And on what's interesting about this one is this back wall here is a concrete shear wall that separates the parking garage area from this building. They are physically separate, but that's a little different setup. And we'll talk a little bit more about the concerns that come when you have vertical structures that are of concrete or steel tied in with the wood. Okay, where are these buildings being built? A lot of them are up in the Northeast, Portland, in the Seattle area. You'll also find, you'll find them in every state. Every single state does have at least something. North Dakota, not a whole heck of a lot, but at least it's something. The blue ones are the ones that are either started or built, and then the gray are the ones that are in the design process. What I find interesting, if you look here at the numbers associated with it, there's actually 833 right now, 833 in the design process. While there's, and this goes back to to 2013. These numbers. That's when they started counting. So you can see the 738 built, but 833 in the design process. So what you would expect to see over time is that the design process buildings will move up to the as you know the built or under construction part. So you should. This to me tells me that there's probably a, we're going to see some acceleration in this type of construction. And that was really the first thing I want to do, is just bring an awareness to everyone that this is out there now, and that it appears to be accelerating. You can see that just from March to September, there was a growth of 90 some buildings into the design, and a similar number, almost 100 in the under construction. So it is definitely a growing area. It's still a small number, but it is definitely growing. Okay, now I want to talk a little bit about how the mass timber is different than light frame, the typical house construction that you see, or commercial buildings that use normal frame construction. The biggest differences really come in the type of components that are used for the structure. In light frame construction, you're looking at 2x4s or 2x6s for the vertical components, the studs in the wall. And then the horizontal may be 2x6, 2x8, 2x10, or even 2x12s. Or you may see laminated veneer lumber, especially where you're looking for larger spans, something that has to go across a bigger distance without any kind of support in between. And now we'll look at a couple of examples of each. So this is the mass timber. You can see you've got the beams and the posts that support. You can see right in this area here, there's a hanger that actually, didn't want to do that. You can see there's a hanger that helps to hold the beam in place on the post. And then the decking, which in this case is either dowel laminated or more than likely, nail laminated would be sitting on top of the beams. Okay, different types. Oh, sorry. Light frame construction. This picture here is actually sort of a hybrid. What this one is actually my house. So I'm sitting up here in the corner right now. But so what you've got is a bottom plate and either 2x4s or 2x6s, and then a couple top plates. In this case, these don't actually even support the floor joists above, but these are 2x12 laminated veneer lumber here that will support from wall to wall. So the interior walls in this is actually a shed house or a barn dominium. It's really a post and beam type outer structure with just interior added in after the whole structure was already built. You can see on the outside walls here, there's actually horizontal 2x8s that provide support between posts that are about 10 foot apart. So it is a little different than typical, but I used it for the picture of the interior frame construction. Okay, mass timber examples. You got cross-laminated timbers. This is sort of a plywood on steroids is probably the way to look at it, where the grain on one layer runs perpendicular to the grain on the layer above or below. The advantages here would be dimensionally pretty stable, and it'll have really the same structural strength in both directions. In glue lam here, everything is oriented in the same direction. You can see you'll see a lot of this in the posts. So in this example, these are glue lam, and they run just, everything is running up and down in that. Nail laminated timbers here, kind of sort of like the glue lam, except that they're nailed together on edge, so that everything, so it's face nailed and one's nailed to the next to form a large panel. This would be a typical panel that would be used on a floor. And in this type of product, you'll see that there is a definite direction that they should be used. Your larger span can run this direction, and a shorter one this way across the grain. Dowel laminated timber is very similar to the nail laminated, with the difference being that instead of nails, you're using dowels. The dowels typically fit very, very tight, and actually to the point that the manufacturer will use a moisture difference between the main components here and the dowels, so that you'll dry the dowels will be dried down to where they will shrink in size slightly, and then the moisture will be a little higher on the actual dimensional lumber that's used. And so when it's pushed in together, then they acclimate, you'll see the dowels swell slightly, which will increase their holding power. Advantages of mass timber. The first one is really decreased weight. What you'll see, when you compare to other types of construction where you can have large spans in between columns, such as concrete or steel, obviously the weight of wood is much lower. The advantages there is really that if you don't have as much weight above the ground because of the structure, then that means a smaller foundation. It also means that you actually have, because there's less mass up there that can be swinging around as there's an earthquake, and plus the flexibility that's inherent in wood, you actually have some improved earthquake resiliency. And another use here is because of the reduced weight, is that you can use mass timber over an existing building. Out in the Northeast, where I actually do my underwriting, mostly New York, you'll see a number of projects where they're adding stories on top of an existing building, and this really lends itself well to that, because you've got less weight up there that you're adding. And then some of the other advantages, sustainable renewable materials. The first question that comes with all of this mass timber is, well, does this deplete the inventory of trees? And no, this can be sustainable quite easily. There are actually more trees planted every year than are harvested. And the advantage of mass timber over heavy timber, being, large single piece wood structures, is that because this is made up of smaller wood, it actually can be harvested out of smaller trees. So you can get into, you don't have to have old growth forests in order to create these beams and posts. An interesting fact, and I actually have an additional fact that I just read about yesterday, is that while wood products only they account for 47% of the industrial raw material in the United States, but yet the process of making them only consumes about 4% of the energy. Whereas in concrete construction, the actual cement process of making the cement, actually, I read yesterday anyway, accounts for 8% of the energy that's used. Seems like a large number, but it is. I guess it's right. Okay, carbon footprint. The carbon footprint of the building is really it's trying to measure the lifetime, across the lifetime of the building, how much carbon is used up during that process. And of course, the advantages of mass timber is you're actually sequestering large amounts of carbon in the building structure itself. And because the manufacturing process has a relatively low energy consumed in order to create it, you can actually get to where you're carbon neutral in the construction of the building, and then across the lifetime, you get normal heating, cooling cycles, and that, but the footprint change is much less than for other types, steel and concrete in particular. Okay, offsite fabrication. This is an area that I'll show you a few videos of kind of the process, but the big thing here is that in mass timber construction, really you're looking at construction that starts off-site. The materials that come to the site are already prepared to the point that they can just be put up into place. So if you think in terms of that IKEA table or whatever chair that you bought and then you assembled and everything fit perfectly, that's really what is being done with the mass timber too. So the difference here, instead of bringing raw materials to the site that are cut and assembled in place, with the mass timber, you're bringing completed panels. Everything's already has all of the areas that fit together are already machined through a CNC machine process. If you're not familiar, CNC is computer numeric control. So it's the big machines. You think of milling machines and lathes and things like that. Well, they have it for wood too. These are massive machines. They can do massive panels and beams, and can cut out the slots necessary for any connecting pieces, such as those hangers that I showed you earlier. And then the kit, obviously these are big pieces. This isn't like your IKEA end table, but these are big pieces that will come on semi trucks. But the advantage here is because they're developed offsite and everything is prepared. Each one is going to be numbered sequentially, so that you can actually have the semi delivered to the site, and the crane can pick off the pieces one by one in the correct order. They can actually be stacked on the semi in the correct order, so that they can go straight up onto the building and just continue right along through the entire process, which means you really need very little space to hold materials. There's not a large area that needs to be set aside. In fact, we'll talk a little more about that with when we go back and talk a little bit about lessons learned on the 111 East Grand job that was in Des Moines. And because this is all CNC controlled, you can maintain very, very tight tolerances, plus or minus a 1/16 of an inch, and probably less in many cases. And also because everything is already prepared to go up, you really need a much smaller crew, and because they're lighter, you need a smaller crane, and they can go up pretty quick, and they're relatively easy to handle. So it can go up pretty quick. Everything I've seen on how long it takes to build this kind of a building is about half of what you would expect in a similar steel structure. And also less people too. So you combine, so when you're looking at worker hours to actually get the building up, it'll be significantly less, because you've got less people plus less actual calendar time or work days to get the building up. So now we're going to look at a couple of examples. The first example is Brock Commons. It is a job that was up in British Columbia, University of British Columbia, 18-story building, 9.5 weeks to complete the structure and get it enclosed. We'll just play all the way through this. So you can see they did have a 1-story podium here. Three weeks in, and they're already up on the 5th floor. And time to install a column, 5 to 10 minutes. Doing 2 floors a week. Okay, they made the wood structure complete, 9.5 weeks. Wood in the building, 2,233 cubic meters of wood. That's a lot of carbon that's been held. When you talk about carbon sequestration, one of the things is that as long as that wood continues to exist, that carbon, that that grew those trees in the first place, you know, with the CO2 and photosynthesis and all that, that carbon stays within that wood and will be there indefinitely. It's only if you were to tear down and it decomposed, or if it were to burn, if you were to burn the wood, that the carbon would be released. So it's possible if this wood is recycled that it would never go back into the atmosphere at all. Okay. We'll get rid of that. The next one we're going to look at is just a small piece of a video where you can see kind of the construction process from up close, where they're talking about the cost savings that comes from the wood and the weight and the less materials or less labor costs.
Advantages of building using mass timber often include construction time and cost savings. The sources of these savings will vary from project to project because of the uniqueness of buildings. But in general, savings come about because of the relative lightweight of mass timber elements compared to other construction materials. Often this means being able to use a smaller crane. Because of the lighter weight of structural materials along with smaller cranes, we also see smaller crews. Because CLT decks and wall panels have inherent structural properties, the supporting structural frame in mass timber buildings often consists of fewer individual components. This means fewer pieces to lift into position, meaning faster time to completion of the structure. The net result of these changes in the construction process means a faster construction time, which opens the door to potential cost savings.
I hope you've enjoyed getting a chance to look at the STEM building on the campus of Michigan State University that's under construction. Like I said earlier, this is something that very few people in the United States have gotten to see before. So I hope you've enjoyed this glimpse into something that we expect to see more and more of in the United States over the coming years. Be sure to come back to campus in the fall of 2020 when you can visit the STEM building after it's been complete.
To find out,
I don't see myself going to Michigan State University, but if any of you are grads, I guess that's okay. I'll stick with my Iowa State and Drake University, please. The last video I want to show you here is actually the CNC machining process. This is a short minute-long video, but it gives you some kind of an idea. Now what you're looking at here is actually timber framing for what would be a builder of a home. But the only real difference here then in the process is seen is going to be in the wood being one piece versus laminated that you would see in mass timber construction. But similar machines, similar tooling. Look at the precision at which it cuts that angle out. Just hits it exactly right. This is a automated tool changer. Let's see, okay. other advantages of mass timber construction, thermal performance, with wood, and it has some insulating capabilities on its own that are about 10 times that of concrete and 400 times that of solid steel. So one of the advantages then is you don't really need any
Hey, Mike, are you on mute? I think we lost you for a second.
I think I lost it. I got a recording in progress thing that talked to me for a second. I hope that's where I lost it.
Thank you.
Thanks, Laura. So there is a new Walmart headquarters that's being built around the Conway, Arkansas area, or down near its current headquarters. And Structural Am has built a new facility down there. Prior to that, a lot of the manufacturing, even for the building here even in the here in Des Moines, that material came from up in British Columbia, and also from Europe, and was shipped over.
Hey, Mike,
Yeah,
your screen share also was lost in that little glitch there. If you want to reset that, thank you.
yeah, thank you. So I figure out how to do it. Oh, let's see, where is that? There it is. Okay, hopefully we're back.
Yeah, looking good. Thanks.
Good, thanks. Okay, so the disadvantage of having the manufacturing capacity away from where you're at is these are fairly large components that need to be trucked in, and of course transportation, logistical costs, timing, all of that is more of a problem the further that everything has to go. And so I think having Structural Am's new facility down in Arkansas will help to open up the Midwest a little bit to more of this construction. Project costs for mass timber have been higher. What I'm seeing now, a lot of the materials are somewhat dated, 2, 3, 4, 5 years ago. And you'll see now that the more recent reporting of costs on projects that I've seen show that they're pretty close to being the same. And then I've even seen a couple cases where the costs were reported to be cheaper than what they would have expected out of a steel or concrete project. A lot of that cost savings is coming from the decreased labor and decreased time. So that will probably continue to build. I think you've probably all seen that labor costs on construction are going up, and just the ability to even find workers when you can find somebody to pay to do the job is becoming more difficult. So less people on a site would help in that way also. Limited expertise. This is still fairly new, especially in the United States. But there are some areas that have expertise that can help. So there, one of the things with mass timber is that because of the design and the manufacturing work for the components is done up front, you really need all that engineering and design right on the front end. And then that's coupled right into the manufacturing process. And so this stuff all takes a while to get there. And with limited experience in this within the country, the number of engineering and architectural firms that have had experience is somewhat limited. I saw a video from on the Ascent building, which, by the way, that came from the PBS station up in the Milwaukee area, I believe, and it actually interviewed the lead architect on that job, and he said that he had never built a mass timber building before he decided to build the world's tallest one. So he said he knew about 5% of what he needed to know. Boy, talking about jumping into the deep end. So that is certainly confident in his abilities, I guess. But that that's kind of what you see is that there are a number of firms now that have done some, and you'll see over time, I think, that it'll start to spread out a little bit, and more people will gain the expertise, but it's still right now fairly concentrated into just a few people. On the plus side, Woodworks, the Wood Council product, or Wood Products Council, is a group that's part of the wood industry, trying to help to push these products along. Well, they've got people all over the U.S. that can help with the process, with the development, and I talked with 3 or 4 different people. I talked to the regional director for the Northeast U.S. I talked to the guy that was kind of does all the training and trying to build the number of buildings, trying to really grow that. And I talked to one other person that was from the Southeast that was a regional director down there, and all of them were very, very welcoming. And so if anywhere along the way you have questions about this as a possibility, for your company, you can reach out to these people, and they're very thankful to have insurance companies that are willing to look at this as an opportunity, for them to help grow the business. One of the other disadvantages here is really building codes. The 2021 International Building Code is only in about a fifth of the states right now, so it's still making its way. And actually, there's a 2024. It's about it looks like it's every 3 years that a new international building code comes out that changes things, tries to keep up with technologies. And you'll see in another slide here in a little bit, kind of from 2015 to 2021, the changes that allowed this tall timber construction within the mass timber to start to happen. But you'll see that there are still a number of states, New York as an example. The city of New York has its own separate from the state of New York. And they're still on a 2009 International Building Code. So And so they're limited right now to 6 stories. There was just recently a condo building completed in Brooklyn. That was, I believe, a 6-story building. But there's not nearly as much as you would have expected from such a large metro area. And that's because they're just not up to date on the building codes. When I talked to somebody from Woodworks, they had indicated, I believe it was the Northeast Regional Director, that there's talk of New York jumping ahead to the 2021 and skipping the ones in between. But and they said it's any day now, but they have no idea when it'll happen. So I guess that's I don't know how that's any day now, but that's the way it was described anyway. So, you know, when it does happen, they'll probably make the leap and be able to do that kind of construction. But for now, they're pretty much still limited to 6 stories out there in New York City. And another disadvantage right now is a lack of knowledge within the insurance space and in the financing of these projects. On the insurance side, ISO several years ago now did a paper talking about mass timber construction and how it was different than frame construction, but they said they really didn't have any reason to separate mass timber out from standard frame. So if you were to look, you'll see that the mass timber still fits within the frame construction definition. You know, eventually maybe that could change. We'll talk a little about fire coming up here too, and so maybe you can see some differences here. And also then on the financing side, mass timber, you know, because of the way it's kind of designed and manufactured on the front end, there's a lot of value add that's done before any materials ever get to the site. You know, they're already machined, they're already ready really just to, you know, kind of put up. It's not the normal S curve you might see in construction of a frame building where raw materials come to the site and then slowly over time as walls go up, you know, get put together and go up, you know, the costs start increasing. There's a lot more costs before it ever hits the site, and then it goes up quickly. So that changes how early in the process the financing needs to get the cash out there to pay for all of these materials that are coming in already pre-finished. Mass timber fire rating. You know, one of the things that was necessary in order to allow for the tall buildings within the mass timber classifications is being able to meet the fire codes, 2 or 3 hour codes. And so you'll see that there have been testing done, you know, and it continues today. There's still more and more testing, but what they're finding is that mass timber acts more like a tree than it does like normal, you know, 2x4, 2x6 frame construction. And so you'll see, well, here the example is a 5-ply cross-laminated timber panel, which is about 6 inches or 7 inches thick, was able to carry the load on it for over 3 hours, you know, far exceeding the 2-hour standard. So, you know, and you'll see in the next slide here how that kind of plays out in the actual wood itself. So when the dimensions needed to carry loads are determined, there's in order to meet the fire rating, they have to be what is essentially oversized so that as they burn down, then you can still meet the rating. What you see here on the right hand side is the charring on the outside of the burning piece of mass timber lumber, for lack of a better term, I guess, will actually act as an insulator to keep the inside cool. And so it slows down the process. If any of you have ever, you've seen how fast when you use kindling to start the fire in your fireplace, it goes quick. But yet the large logs can last for several hours before they're burned up. And that's really just because as it continues to burn in, deeper and deeper, it just takes a while, and that outside actually helps to slow down that process. Or with a 2x4 or 2x6, the normal dimensional lumber that's used in frame construction, you've got wood that goes up quick and is gone. Now the lumber that's actually in here is no different than those 2x4s and 2x6s. This is still, spruce or pine. It's still the same. It's still the same lumber. The difference is just because it's made bigger, that it actually slows down the process. And individual 2x4s would lose their structural, load carrying ability very quickly, where this won't. Okay, 2021 International Building Code. When you look back at 2015, this type 4, now HT, this was HT heavy timber. You're limited to 6 stories, 85 feet maximum, but now there's new classifications that let you get up to 18 stories, 270 feet, large area. And this is across really all occupancy types too. And actually for 2024, this type 4B that was created, the type 4 became type 4 HT along with type 4 A, B, and C when 2021 came out. So you'll see that now they're, it's split 3 different ways. And one of the big difference between the 3 is how much covering there is, fire resistant covering, drywall, that gypboard on the in here. It's almost all of the structure needs to be covered. In this, there's a percentage that can be uncovered, and actually with the 2024, that percentage is going up to 100%. As continued testing has shown that it'll get the fire rating needed in order to build the building, even without that protective layer on the outside. And then here we're already at 100% in the type 4C. Okay, design challenges within the mass timber. There's a couple of things that I think are worth mentioning here. The first one being designing for differential movement. If you have any kind of structure that's adjacent to the mass timber that doesn't compress or settle at the same rate, or shrink from the load, such as that Des Moines project where there was that shear wall that was a 4-story concrete shear wall that didn't move, but yet the wood can. So you've got differential movement between the concrete and the wood. So you got to design into that building the ability for that movement to happen and still maintain structural integrity. Another thing that I see a fair amount of papers on and topics in discussions is acoustics, because now you've got bare wood in many cases that, so in order to ensure you've got good acoustics, you really have to start taking that into account. Same thing with floor vibration. You really have to decide, how large a spans you can have, how, and there are formulas for this, but how large can the spans be between supporting structures on a floor that's made out of the cross laminated timber or nail laminated, in order to not get that floor bounce that you probably felt in some building that you've been sitting at your desk in. And then the other area that is still somewhat being worked on anyway is repairability. If you've had a fire, at what point do you need to actually replace structure, and how do you go about the replacing of the structure? Because this is all, you could see how it was sort of in the Michigan State piece. There was really quite a, there was a lot of connection that was made, and then you've got the floor that kind of wraps around the connection, and so being able to get out and replace components while the building is still there is another area that that is somewhat of a head scratcher. But I got some ideas myself, but I'm not the engineer. Okay, the 111 East Grand project. The team that started the project, the architect, the engineer, and the general contractor on this, they really worked with the city of Des Moines in order to be able to get them through the approval process. At the point that they did that, really they weren't. This was back in 2017, so there really wasn't anything. There was nothing in the state. And this was the first dowel laminated timber project in North America for an office building. And so there was a lot of hand holding with the city in order to to kind of help with the approval process, and the city did welcome it. The developer, when it was built, they went and looked at the T3 building up in Minneapolis as a close by example of mass timber construction, and that really helped in the decision-making process whether to go ahead and go with mass timber. Somewhat risky, very interesting developer. He's a fairly young guy. Tim Ripma is his name. He's probably late 30s. His thesis in his master's program at the University of Iowa is actually on how to build out an entire block within the city. And so when he got out of college, he decided, well, that's what I'm going to do. And so he did. So he's got a lot of the East Village of Des Moines, a lot of buildings down there. The team of architect, engineer, and general contractor used a lot of building information modeling, BIM. You may have heard that terminology before. It's sort of a CAD CAM type thing, computer models that bring in everything, all the systems and everything, and the entire structure, and it's all modeled within computers to be able to ensure that everything's going to work. And then also the advantage is when you bring in other models from the other mechanical contractors and and plumbers and electricians, you know, you can ensure that you don't have any clash issues between systems, so that, you know, things are run in places that doesn't disrupt something else. So hopefully this means that the days of a plumber coming in and putting a line from the toilet in and cutting away a large joist is gone. But obviously in smaller construction projects, BIM is still not anything, but in this, it's really an important part because it's necessary to have that model so that you have the manufacturing models ready to be able to cut all of these on or off site before they ever make it to the building site.
Hi, Mike. I hate to interrupt all
Yep.
of your really good information, but we are right at time.
I see that. Holy crap.
It looks like you have answered most of the questions that came in. If you do have a question outstanding, Mike, would you be okay with them emailing you?
Oh, sure.
Okay,
Yeah.
and his email would be mike.neubauer@rlicorp.com. If you have any outstanding questions. Any last comment before I end the meeting here? Mike?
No.
Okay,
There's not a lot left here. Sorry, I ran a little long. This is
that's all right. It's a lot of
more
really
than I thought
good
there would be.
material.
So, yeah.
All right. Well, thank you so much, Mike. I really appreciate all the time you put into this and presenting it to the group today. I just have one quick reminder for those that are still here. Make sure you renew your membership with CPCU and join us for the meeting in February. Thank you all for joining today and have a great week.